Hey everyone, in this video we're going to be talking about tides and the moon phases. So first of all, tides. What are they? Yeah, well the tides are the cyclical rising and falling of sea level due to the moon and sun's gravitational pull. If you look at the GIFs on the right side of the screen, you can see the difference between a high tide and a low tide. Now in these regions, because they're low-lying, there's a huge difference between high tide and low tide. And all of this has to do with how much the sun and the moon are pulling on Earth's water. So tides, what has a larger effect? First of all, the sun is huge and has a large gravitational pull due to its large mass. The law of gravitational attraction, basically the more mass you have, the more gravity you are going to have on your own. The moon is super tiny when it comes to mass, but it's way closer. And because it's way closer, it has a larger impact on the Earth. So mass is really important when it comes to gravity. Super important, right? Sun, huge. Moon, small. But that distance becomes a critical factor. So here is the equation for gravity, in case you were wondering. If you look at the equation to the right, F of g is the force of gravity. G is just a gravitational constant. M1 and M2, those are the masses. So if you want to calculate the gravity between two objects, you have to multiply both of their masses by each other. And then this r on the bottom, that's actually the distance between the centers of the objects. Now it looks like, oh, there's two masses, that's the greater impact, but false. This distance is squared, making it much more of a factor than the mass. So the greater the mass, the more gravity the object will have, for sure. The distance between the objects, though, has a larger impact on the force of gravity. So if you look at this example, if you have a small mass, small distance, you're going to get like a medium amount of gravity. If you have a large mass and a small distance, huge gravity. But if you take large masses and you spread them out, that distance plays a larger factor, therefore you have way less gravity. So even though the sun is way bigger than the moon is significantly closer. So the moon has a larger impact on our tides. So high tide versus low tide. High tide is the side that is in line with the moon. So you can see in the picture, we have high tide is where, oh, here's the moon, and then the high tide is right next to it. The moon's gravity pulls the water. So what we actually have is a bulge of water and high sea levels on this side. Water is free flowing. So if you have enough gravity, it's going to gradually move to that location, and that's what that high tide region is. As the Earth rotates, it moves in and out of the high tide area. Because remember, Earth is rotating in a 24-hour period. So if you were experiencing a high tide, don't worry, you're going to rotate right out of it and into that low tide. Less gravity and pull on the opposite side also results in a high tide. So on the side with the moon, where the moon's like pulling out water, we're going to get a high tide. But on the opposite side, the side furthest from the moon, there's also less gravity because it's further away. So that water's actually going to have less gravity. It's going to swell. We get two high tides occurring at any given point on the Earth. Low tide. This is the side that's at 90-degree angle to the moon. So you can see the moon works there, and then like, oh, 90 degrees to that. That's our low tide side. The water is pulled to the high tide regions from the low tide regions. That's what causes that low sea level. As the Earth rotates, it moves in and out of the low tide area, just like it would for the high tide area. So if you started in a low tide area, 6 hours later, you're going to be in a high tide area. And you're just rotating through these areas where the water is higher or lower. So in this example, notice how the Earth rotates through the high tide and low tide region. In a 24-hour period, most places that are close to the ocean, where it's a large enough body of water to be impacted by the moon, we're not going to see this on Lake Superior, we're not going to see this on our lakes here, but you will see this in large seas and oceans. So in a 24-hour period, you're going to have a high tide, a low tide, a high tide, a low tide. Now the times on here aren't always going to be the same. There are going to be two high tides and two low tides in a 24-hour period, which means you have 6 hours in between each one. So if you're going to the beach, you can kind of plan out your day. But these times won't always be the same. The times on here are designed for when there's a new moon. So if there is a first quarter moon then the times will be shifted. Then at 6 p.m., that would be when you have a high tide. So this is why you want to pay attention to a lunar calendar or to the tidal times if you ever visit a coastal area, because this changes throughout the lunar cycle, the times of the day where there's high tide and low tide. So spring tides and syzygy. This is, again, one of my favorite words. I love syzygy. It's so much fun. It's fun to spell, fun to say. Yeah, spring tides occur when the sun, moon, or the sun and the moon pull in the same direction. So when we have the Earth, sun, and moon in syzygy, or when there's a new or full moon, that means the sun and the moon are going to work together. They're both going to reinforce each other's gravitational pull, and this is when we get the highest of the high tides and the lowest of the low tides. This is also called a high tidal range. It just means there's a big difference between the high tide and the low tide. So anytime these things are in a line, what's happening is they're pulling in the same direction, so you get super high tides and super low tides. So when we have spring tides, this is when you definitely want to pay attention on the coast, because it's very possible that the sea level is going to change really quickly multiple times a day. So if you're hiking by the water, if you're having a picnic, if you're boating, if you're swimming, this can make for some pretty dangerous conditions, and you want to pay attention. That's spring tides. Yeah. Neap tides, those are pretty neap. This occurs at 90-degree angles. So neap tides occur when the sun and moon pull in opposite directions. Instead of reinforcing each other, they're kind of battling for who can pull the most water. This occurs during a first or last quarter moon. Mild high tides and mild low tides. So this would be a good time to hang out by the water when you don't want to have to worry about huge tidal ranges. There'll still be high tides and low tides, but they won't be as drastic. The sun, earth, and moon all make a 90-degree angle. You can see that in the picture. That's a 90-degree angle. And the moon and sun compete for pulling on the water. So the spring and neap tide you can see in this GIF here, as the moon goes through its lunar cycle, you can get a spring tide where you see those larger bulges of water, and the sun and the moon are working together. And then at a neap tide, you can see the water kind of flattens out and evens out around the whole globe. So that's the difference between a spring tide and a neap tide. So why do we care? Well, tides impact a lot of things. There's a lot of different websites out there that allow you to track the tides due to their impact on a variety of things. And that's because it really impacts fishing. High and low tides changes the amount of nutrients that are in the water. It impacts surfing for when you're going to get your swells throughout the day. It impacts hiking, whether or not trails are available. Boating and swimming, it changes those underwater currents and can make for some pretty dangerous conditions. Boating, you have to park your boat. What if the dock is underwater? That's crazy. And this also impacts weather, because as you get this changing of the tide, it churns the water and makes sure that it kind of mixes those temperatures, which can impact the weather. And as it churns the water, it also impacts the different food and all the nutrients that are in that location, which is going to cause fish to eat, mussels, crustaceans, all sorts of things. So even though you're thinking maybe the tides don't impact you, you know what? They kind of do. If you're wondering, does it impact Lake Superior, even though I touched on this before, tides, technically, it is measurable. You can measure the impact of tides on Lake Superior, but it's so small that the pressure impact is way higher. So like if a high pressure zone came in, you wouldn't be able to really see or measure the tides. That high pressure zone would have a larger impact. So that's tides. Thanks for watching, everybody. Send me a comment if you have any questions, and good luck on your astronomy quiz.